Let's now start some example of function. Example of function. Here fx equal to x square, then all are input difference and range are same. So this one x and x square obviously belongs to some rule of assignment, and also this one be a function. And also we create another example of function is fx equal to x cube plus 1. Okay, then f of 0 equal to 1, f of 1 equal to 2, f of minus 1 equal to 0. This one also be a function. Here rule of assignment is x cube plus 1. Okay, and also fx be a function. Now we restrict of the function. That means the function restrict in some domain. Then if a to b be a function. Okay, then the restriction of f to a0, the restriction of f at a0 into b a0, restriction of f at a0 to be the function of mapping, to be the function mapping from a0 to b. Okay, restriction of f at a0 whose rule is AFA such that A belongs to A0. Okay, this one so simple. Now we give some example. That means this gives some restriction of F, restriction of function. That means restriction in domain. So then we obtain some rule of this. Now we give some example of some function. Okay, so familiar example, we considered this one. If r to r f square, if r to r fx equal to x square, if r plus to r, if r plus to r gx, we write it gx equal to x square. Here write g, not f. Okay, and also we write h r to r plus, then hx equal to x square, and we write k here r plus to r plus, kx equal to x square. Then we see the figure, we see this figure. This one equal to f. Okay, here domain is whole and f is in this way, and this one just r plus, thus just r plus is the domain. Then this one is g, next r is the domain and just r plus. That means this above portion. this above portion. This one is h, and obviously now this portion, this one equal to k, just this portion r plus 2 r plus. In this way we see that if we sum functions, it's not 1 1 or 1 2 both, because here r to r, and here this functions is 1 1, just 1 1. Okay, and this functions on 2, and this functions is 1 1 on 2. So when we write this one, when we write 1 1, when we write 1 2, then we give some definition of 1 1 function and on 2 function. If a function, that means we write this f is not neither 1 1 nor on 2, or g is 1 1, h is on 2, k is 1 1 on 2, then we write the definition of 1 1 and on 2 function, that means injective and surjective and bijective function. Okay, then injective function. A function if a to b is called injective if each element of a, that means each element a going to some element, each one element of b, that means a to b, just one element. Okay, one element going to one element, then this one is called 1 1 function or 1 to 1 function. Okay, that means just here if we write 1 2 3, then here 4 5 6, if a is 1 2 3 and b is 4 5 6 7. Okay, or another things, but if a to b just in this way, 1 going to 4, 2 going to 5, 3 going to 6, then if a to b is called 1 1 or injective function. That means for each pair of distinct points of a, their images under f are distinct. That means each pair of distinct point, that means if a to b be a function, then each pair of distinct point of a, their images must be distinct. Then f is called 1 to 1 function. Okay, so or injective function. So we see this example of injective function. Also we write here a1 not is equal to a2. This implies that f of a1 not is equal to f of a2. Okay, or another way, in converse way, f of or in contra, f of a1 equal to f of a2 implies that a1 equal to a. In contrapositive, okay, this one and this one is same. In contrapositive way we write in this way, this functions, then if f is, then f is 1 1, then f is 1 to 1 or injective. Okay, so we write it and we understand also. Now we start surjective function. Surjective function is an important one. Is an important function. Also we discuss it. Surjective function. Surjective function. Okay, just we write it, if a to be a function, then f is called a onto or an onto function or surjective function if f of a equal to b. That means which one, each element of v have a pre-image in A. Okay, so how we handle, we write this definition, we're going to the sum this 1 2 3 and here b equal to considered 4 5. Okay, then 1 going to 4, 2 going to 5, 3 going to 4. Okay, then f of a equal to b. So f is onto function here in this example. Now we write bijective function, and here also we construct this example, then obviously h be the onto function. Okay, h x equal to x square, h is r to r plus, then h onto function. Now we construct bijective function means one functions which both f a to b function be a function which is injective and surjective, that means 1 1 and 1 2 both, then f is called bijective function. That means two conditions hold. If a1 equal to f a2, if a1 a2 belongs to a, this implies that a1 equal to a2, and f of a equal to b. That means if b belongs to b, then there exists a belongs to a such that this one hold. These two conditions, this one is 1 1, this one is 1 2, these two hold, then we call it bijective function. Okay, so we take some example of bijective function to easily we done it. We take some example of bijective function. If a to b, a is 1 2 3, b is 4 5 6, then 1 to 4, 2 to 5, 3 to 6. These functions f a equal to b also, and here 1 1 also, here 1 1, here 1 2, then 1 to 1 and 1 2. So f must be bijective. Okay, next we also define this functions k r plus 2r, k r plus 2r plus kx equal to x square. Then this one also bijective. Also this one is injective and surjective both. Then this one must be bijective. Now we start composition or composite of functions, two functions, composite of two functions. Okay, composite of two functions. Let f a to be a function and g c b to c will be a functions, because then we write g composite f. Okay, g composite f, how? A to c, because f a to b and g b to c are functions, then g not f a to c be defined as g not f x equal to g of f of x, where x belongs to a and f of x belongs to b, and g of f of x belongs to c. Okay, and so g not f is the composite of f and g. Okay, now we write it we write it another way. How we define this one also defined, and how we define in another way. We define this way simply: g not f equal to a to c, and g not f, which is contains some rule. Which rule? ac, where 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 for some b belongs to b, fa equal to b, and gb equal to c. Okay, with some different some rule is a rule, which rule is this one. Okay, in this way we also define g not f or g composite f, or composite of f and g. We write this one also, and then the range of f equal to, if composite g not f define when define this, define if range of f equals to domain of z. Okay, this one is hold, then g not f define. And in this way we write some example of composite of two functions. Okay, we give some example of composite of two functions. If r to r such that fx equal to 3x square plus 2, and gx equal to gr to r 5x, gx equal to 5x. So is the example. Then g not f equal to obviously r to r, and define as g not fx equal to g of 3x square plus 2, and g of 3x square plus 2 equal to this one, then 15x square plus 10. Okay, now f not g, this one also r to r here, and f not g also defined as f not g y done, and then f of 5y gy equal to, and this one 3 into 5y square plus 2, that means 75 y square plus 2. Okay, if f of g naught y equal to 75 square plus 2, then these two are different. This one is also composite of f and g, here composite of g of f. Okay, but these two are different. That means composite f not g and g not f, two are different. In this way, in this example, obtain this one. And now we discuss some functions which are the inverse. That means if inverse of some functions. Okay, when inverse of some functions exist, inverse of a function. Now, one function, if f is bijective, that means both, that is 1 1 and on 2, both, then a function inverse exists, then a function inverse exists. If a to b if f a to b be bijective, then f inverse b to a exists. Okay, so we write some example, we write some familiar example to construct if a to b, a equal to 1 to b equal to 3 4, then 1 just 2, 1 just 3 and 2 just 4. So f inverse defined by b to a. Just f inverse, how f inverse is handled? F inverse of 3 equal to 1, f inverse of 4 equal to 2. That means here 3 going to 1 and 4 going to 2. In this way, we construct another example also. Which example? We learned in previous way. K r plus to r plus kx equal to x square. Kx equal to x square. We now k inverse. Obviously, because this one is bijective, this one also bijective. So k inverse r plus to r plus exists. Then this one, obviously k inverse y equal to square root of y. Okay. So today we also discuss some functions. Now stop.